Hello everyone. Today we're going to continue our conversation about objects. So one of the things to look at is how do we extend what we're learning in this class and think about how are objects and object-oriented programming used in the real world. So right now we're able to access and modify attributes directly from a class. Right, so we can say I've got my make of my car is this and I'm changing it to be that. However, when we think about what we actually would use, say, in industry or specific techniques, we'll see that there's things that we can do to accommodate thousands of people, many, many millions of lines of code on a large project. So just to give you a sense of scale, I'm just going to go through a couple of these. So we see that maybe your final assignment near the end of the class is about 250 lines of code. The average iPhone app might be 50,000 lines of code. Again, kind of increasing. We see Google Chrome, Android, car software. It keeps getting bigger until we think about, let's say, all, for example, the Google services. Could be 2 billion lines of code. So when we're looking at writing software that has 2 billion lines of code, written over decades even, let's say in the case of something like Microsoft Word or Mac OS, thousands of engineers across the world, we have to kind of develop more robust ways of writing code that can be used and read, in years in the future by many different people. So we're just going to introduce two of those ideas. So one of those is to think about how could we protect attributes. So remember we have this car, we have a make, a model, and then how many miles per gallon it gets. Okay, and so we started out to be 0 as default, just to say, hey, we don't know what it is yet, and then we're going to run a test later on maybe and figure it out. Okay, well let's say you have this code and you can print out the car mileage directly, right, .mpg, and then you can say the car mileage is negative 100. Well, this shouldn't be allowed. A car can't have negative 100 miles per gallon. Well, that would be pretty remarkable. I'm not sure how that would even work. So we have to think about how do we solve this problem to fix that, right? And so we don't want to have the attributes being able to change directly from main. Rather, we'd actually like to provide a method that will allow us to change that. Now, if we use a method to do this, the method can enforce the error checking. So you don't have to put the error checking, is the miles per gallon less than 100, less than a 0? You don't have to put that on main. You actually can control that when you build the class. And this is something that we call a set method or a setter. Okay? And the set method is actually pretty straightforward. It's often going to be set blank, whatever your attribute is, name, age, whatever. And it often generally only takes one parameter. And that one parameter is going to be what is the new value that you want to assign to this parameter. So set age is going to take one parameter, age. Right? And it typically does not return anything. Let's just look at one in action here. So now we have a set miles per gallon method. And so look what it does. It's very simple. It simply takes this new miles per gallon, and it says if it's less than 0, then go ahead and just assign it. And if it's not, meaning if it's greater than 0, if it's greater than 0, we can set that value. If it's less than 0, then say it's invalid. And so now, when we try to set a miles per gallon to be negative 18, it prints out a message, and notice that this does not change, right? There is no change to that, because it's invalid. So now you've guaranteed that if you use the setMPG method, you'll always be able to set a valid method. Valid MPG. Again, if we change to, say, 23, no problem. 23 is valid. That's okay. This is an okay number, and so. So that's typically how we use a set method. So it's very common in object-oriented techniques where you may have a set method for many of your attributes. Again, if you have an age and a name and an address, you might have a set name method, a set age method, and a set address method. And it would often all be very simple, like this. They take a parameter, they determine if it's appropriate to change it. If it's appropriate to change it, they'll change it, and if not, they do nothing or they show an error, etc. Okay. Now, another sort of flip to this is, for convenience, we might have another kind of method that we're going to call a get method. And let's explore what that might look like. So imagine that we're building a nutrition program, and so we have a fruit class, right? And so the fruit class is very simple. It has a name. Simply there's the name, right? So we have, an example would be kiwi. And then we might have a list of all the nutrients, okay? Now, we may have chosen to store the list of nutrients as a list. You could certainly use a dictionary or something else. Right, so here you can see this is some nutrient value and some other nutrient value. Now, we would know that this is going to be vitamin C, so we technically know that this is vitamin C and this is vitamin A. Okay, so you have to know what those columns are. Now, if we want to access those two attributes, though, right, how would we do that? Well, we've learned the techniques to do that. We could do something like this. We could say kiwi.name has kiwi.nutrition list, so that's going to look inside here. Here's my nutrition list. And we know that position 1, which is here, is going to be my vitamin A. And we could print out kiwi has 280 milligrams of vitamin A. Great. Okay, no problem. We could do that. We've done that before. We just have to be careful when you look at the list. You navigate to the particular index, and that's fine. But what if the index doesn't exist? What if I want to get fiber? And what if, for example, this class doesn't have fiber? Well, then it's going to crash. So is there a better way, a more sophisticated, robust way we could retrieve data from classes? Because you can imagine the class could get very complicated, and we can have a list inside of a dictionary, inside of a list, and there's lots of things lots of data to access. So again, instead of accessing the data directly, we're going to use a method, just like we did with the setter. And by using a method, we can make sure the value exists so it won't crash. It also makes the code easier to read. We don't have to worry about what, in the case of the fruit, what kind of index we were using, or however that is. And so the way that we do this is we use what's called a get method. Okay? And it's called get because you are returning an attribute. Get methods are very simple, typically. It's get blank. So if you have age, it's get age. If you have name, it's get name. And oftentimes, all of this attributes, all this method is going to do is simply return the value of the attribute. Now, let's see what this would look like in an actual use case. All right, back to our fruit example. We make a method called getNutrition, right? And this nutrition method only takes a string. So the string is going to be whatever parameter you're looking for. Vitamin C, fiber, whatever. And so in this case, we could say if parameter.lower, so if the vitamin C is given, then we return the value in index 1 or 0. If it's vitamin A, we return the value in index 1. And then if it doesn't match, then we return 0 because we essentially don't know. We would assume it's 0 or we assume we don't know. And so now here's the beauty of this. When you go back to this to main, you can say kiwi.getNutrition. And then you just pass in what you're looking for, vitamin A. What's really nice about this is now when we are in main here, we don't have to worry about what column we're looking at, what index we're looking at, whether we're using a list or a dictionary or whatever. That we don't care. That's all washed away. All we have to do is worry about this method, getNutrition. That's it. And so essentially it's made us using this method in this class in main much easier. Or sometimes we would say in other programming classes, as you learn more, we've abstracted away some of the complexity by encapsulating the class and all its details in a more clever way. Again, if we keep going, now we can ask for fiber. Right? Well, there's no fiber, so instead of crashing, it says 0 milligrams of fiber. Right? And so we could even take this one step further, which is like, well, kiwi.name is fine, but we could actually carry this and make them all get methods. And so we could say, I'm going to make a method getName, and all it's going to do is just return the name. And it's how you say kiwi.getName. Okay? So this one may not be as useful, but it does kind of clean up our code, makes it easier for us to navigate, always using methods and not having to access the attributes directly.